Majority of the world's oceans are blue because pure water is blue. However, oceans of today look different from the oceans of 20 years ago, researchers found in a new study. Around 56% of the world's oceans have changed color, with the blue waters becoming greener over time, according to a study published in a journal Nature. Tropical ocean water near the equator has been especially impacted. But why the ocean's color is changing? We can say that ocean's color is changing as the consequence of the climate change. Hello and welcome to It's Tomorrow News. I am Hena Talati. The ocean's color has changed significantly over the last 20 years, and the global trend is likely a consequence of the human-induced climate change, reports scientists at MIT, National Oceanography Center in UK and elsewhere. In a study appearing today in Nature, the team writes that they have detected the changes in ocean color over the past 2 decades that cannot be explained by natural year-to-year variability alone. These color shifts, though subtle in the human eye, have occurred over 56% of the world's oceans, an expanse that is larger than the total land area on the earth. In particular, the researchers found that the tropical ocean regions near the equator have become steadily greener over time. The shift in ocean color indicates that the ecosystems within the surface ocean must also be changing, as the color of the ocean is literal reflection of the organisms and materials in its water. At this point, researchers cannot say how exactly marine ecosystems are changing to reflect the shifting color. But they are pretty sure of one thing: human-induced climate change is likely the driver. The ocean's color is visual product of whatever lies within its upper layers. Generally, waters that are deep blue reflect very little life, whereas greener waters indicate the presence of ecosystems and mainly phytoplankton, plant-like microbes that are abundant in upper ocean and that contain the green pigment chlorophyll. The pigment helps plankton harvest sunlight, which they use to capture carbon dioxide from the atmosphere and convert it into the sugars. Phytoplankton are the foundation of the marine food web that sustains progressively more complex organisms on up to krill, fish and seabirds and marine mammals. Phytoplankton are also a powerful muscle in the ocean's ability to capture and store carbon dioxide. Scientists are therefore keen to monitor phytoplankton across the surface of the oceans and to see how these essential communities might respond to the climate change. To do so, scientists have tracked changes in the chlorophyll based on the ratio of how many blue versus green light is reflected from the ocean surface, which can be monitored from the space. The color of the ocean has changed, and we can't say how. But we can say that changes in the color reflect changes in the plankton communities that will impact everything that feeds on plankton. It will also change how much of the ocean will take up carbon, because different types of plankton have different abilities to do that. So we hope people take this seriously. It's not only models that are predicting these changes will happen. We can now see it happening, and ocean is changing. We hope you would have found this interesting. If you want more ideas like this, let us know in the comment section below. Write to us for further queries. Till then, like, share and subscribe our channel.